So here's our next example. Basically here, we're looking at y equals 3x plus 4. I mean, you could graph this using, what do you call it, GeoGebra or Desmos. You could graph those. I use GeoGebra, actually. But basically, what's going to happen is, if you were to graph this, okay, you would get a line like so. Now, notice from the graph, it's crossing the y-axis at 4. Excuse me, at 4. Okay, am I recording? It's crossing the y-axis at 4. I mean, even from here, you could probably see, at least I hope you can see visually, that if you let x be 4, the 3x is gone, and you're left with 4. So if x is 0, we get 4. That's why 4 is called the y-intercept here. Okay? Now, for the x-intercept here, I mean, it's kind of hard to see what it is from the graph, as you can see. So what we do is we can set y to be 0. The other variable, remember, that we set to be 0, so x, that is set to be 0, okay? No, excuse me, we set y to be 0 because we're looking for the x-intercept. So we set y to be 0, okay? And we solve for x. Doing so, I mean, I didn't go through the calculations, but I hope you can see that you would get -4/3 as your x. So this is the x-intercept. That's where the graph crosses the x-axis, okay? Again, the other variable, x-intercept, y, is 0. Okay. Good. Okay, so we have that. Okay, now, before we do some other examples, let me present another kind of graph. What we're going to see here, what we see here is what's called the parabola. Basically, if you have this kind of equation called the quadratic equation, okay? As you can see, the quadratic equation, that's when you have y equals a polynomial of degree 2, okay? Its graph is called a parabola. No matter what a, b, and c are, I mean, a can't be 0, but no matter what a, b, and c are, we call it a parabola. Now, I was going to do this when we consider quadratic functions. That comes in chapter 3, but let me just say it here anyway. If your a is positive, this graph has to look something like this. That's if your a is positive. Like so, okay? It's opening upward, whereas since a can't be 0, the only other choice then is negative, okay? So when a is negative, you have this. In this case, a, it's going to go down. That's if a is negative. Remember, a is the leading coefficient. So a here is negative. Okay? So the graph's going to look something like that. I mean, obviously what a, b, and c are will determine what the graph is, but it's going to look similar to that. What's really nice is we can get the intercepts. I mean, the intercepts in theory are pretty easy to get. Well, I shouldn't say easy, but we can get them. To find the x-intercepts, remember what you do, you set y to be 0. Right? You set y to be 0, and you solve for x. Well, this is something we did in 1.2, right? You know, we saw different ways of solving that kind of equation. Namely, we had, you know, the quadratic formula. We could also factor. So we can use either one of those methods. I mean, there's other methods we can use, but those are the two we saw. For the y-intercept, you set x to be 0, so that's what happens here. Remember, you're always setting the other variable to be 0. That's what you're doing. You're setting the other variable to be 0. For x-intercepts, for x-intercepts, you set y to be 0. For y-intercept, x is 0. So we are going to have to use stuff from 1.2. And here's an example. Let's say we want to graph y equals x squared. Okay? If we want to graph that, right? Well, all we can do, I mean, I guess now we have graphing calculators and graphing software. If we were to graph that, though, by hand, without those tools, we would have to make a table like this. We have to see what's happening for different x values. In other words, we need different solutions to this equation. So we would have y equals x squared. Okay. So for x equal to -2, right, we would have y equals -2 squared, which is 4. So what is this saying? When x is -2, y is 4. So from here, we get this. So this is a solution to this equation. And so this point is on the graph. I mean, the graph I actually do have down here. And you could see that -2, 4 is on the graph, right? That's actually point A. A. As you can see. For for the next one, when x is -1, well, we calculate y, as you can see. So -1 squared, right? That becomes 1. So when x is -1, y has to be 1. So we get b, as you can see. When x is 0, y is 0, right? Well, so b was -1, 1. When x is 0, right, we get y has to be 0. So because of that, the origin is on the graph, right? When x is 0, y has to be 0. So this point is on the graph, and that's what point C is. And you keep on going. So the next one is 1, 1. The next one after that is 2, 4, and so on. For 1, 1, right? If x is 1, right, you calculate y. Y is also 1. So 1, 1 is on the graph. And 2, 4, same thing. And this is what the graph looks like. It actually does keep on going up and never stops. But the graph does look something like this. Okay. And again, this is a parabola. It's an example of one. Okay, that was good. Now, what if we had this one here? Oh, wait, I forgot to say something. I'm sorry. Notice that if we let x be 0, right, we're finding the y-intercept by setting x to be 0. And what do we get? We get y has to be 0. In other words, it's crossing the y-axis through the origin. So 0 has to be the y-intercept. When you set x to be 0, that forces y to be 0. And so 0 is the y-intercept. 0 is also the x-intercept. I mean, hopefully you can see from the graph that if we set y to be 0, the only way that can happen is if x is 0. In other words, the only y and the only x-intercept is 0. That's really what I'm trying to say. Hopefully I explained that well, but I think I did. Okay. I didn't do it here, but if you set y to be 0, you would have x squared is equal to 0. And solving that, you get x has to be 0. So in this example, look, x and y-intercept are both 0. Okay. Okay, here, okay, what we have here now is this equation, y equals 3x squared minus 3, okay? Now here, if we want the x and the y-intercept, we want to get, okay? Well, for the x-intercept, we set y to be 0, right? That's what I'm doing here. So by setting y to be 0, this equation is what we have to solve. And again, we're back in 1.2. You could solve this using the quadratic formula if you want, but I just factored. Basically, you can factor out a common factor of 3. So 3 is out. Then you have x squared minus 1. And x squared minus 1, we can factor that. There was a formula I gave you called with the difference of two squares. And from there, you get x minus 1 times x plus 1 is equal to 0. And the next thing we did at 1.2, remember, was you set each factor equal to 0. Okay, you set each factor equal to 0. Not 3, of course. 3 can't be 0, so we kind of disregard that. X minus 1 we set to be 0, and x plus 1 we set to be 0. And from the first one here, we get 1 as a solution. From here, we get negative 1. So I didn't graph it, but this has two x-intercepts, 1 and negative 1. The y-intercept is easy. You just set x to be 0, and you get the constant term. Because 3 times 0 squared, that's 3 times 0, which is 0. So minus 3 we get as our y-intercept. Again, it's just setting the other variable equal to 0. Before I get to this, let me pause the recording.